All right, so yesterday we learned about double integrals and how to evaluate them. So now you're pretty good at that. But you're only pretty good at evaluating them. Well, you're pretty good at evaluating them, but only if the regions were rectangular. So today we're going to talk about two different types of regions, which we can always kind of reduce any region to. There's type 1, which looks something like this. We have some curve. We'll call it g2 of x. And then below that we have some other curve. We'll call it y equals g1 of x. But we can trap the region we're looking at between these two vertical lines. We'll call that x equals a and x equals b. And then this then would be your region R. So this is one type of region. A region where we can find a curve in the y direction for the lower and upper bound, and then we can just say that those two curves are between these two x values. Okay? That's to keep things simple.
That sounds like what we did last year in calc, where we had to do like the area under like two curves that cross each other.
Oh, with the disc?
You're talking solids of revolution.
No, this is the other one. It's like the area under. So it's like one graph.
So you do the integral of this minus the integral of that to get that, right? But we're not finding this area. Remember, we're just trying to define the region so that we can find the volume above this region R. Okay, so type 2 would be the other direction. So perhaps we have some function, let's say x equals h1 of y. And then over here we have x equals h2 of y. But we can find horizontal, or at least lines in the y direction, so we'll say y equals c and y equals d. And then this would be the other type of region. Okay? So those are the two types of regions we're going to look at. And depending on which way you want to interpret the integral, that determines how you set it up. Okay, and this is very important. Okay, so if it's a type 1 region, the setup for the integral f of x y dA is going to be the variable that you have functions for. It goes on the inside. So that means, in this case, we have functions that are bounds for the y. So we'd go dy first, and then dx. And then the bounds for y would be whatever those curves are. So the lower curve would be g1, and then the upper curve would be g2 of x. And then nothing changes in the x direction. The x is still between a and b, so we say exactly that on the outer integral bounds. Okay. Now, if you want to set it up the other way, so if you have some clear functions that are bounding the x values, then you would start by integrating with respect to x first, and then the bounds for x, you go from left to right. Okay? So you would be, lower bound would be h1 of y, and the rightmost bound would be h2 of y. And then the bound for y would still be lowest to greatest, so c to d. Okay, so this is the ways that we can evaluate double integrals. The direction in which you integrate does make a difference because then you have to pay attention to the region that you're looking at and what functions you're going to use. Now, there's always a way to do them both ways. Okay, so if you're given a problem and you want to decide should I go dy dx or dx dy, you can do either one, but one might be a lot more complicated to integrate than the other one. Okay, kind of like what we did yesterday when even though we had rectangular regions, just switching the direction sometimes made the integrals a lot easier, right? So you have to pay attention to that when you're setting these up. So let's do an example. Let's say we want to evaluate the double integral of x plus 2y dA over region D. And here's a sketch. Actually, let's just write it this way. D is region bounded by y equals 2x squared and y equals 1 plus x squared. Okay, so if we do this, I would recommend sketching the region so that you know what the region looks like and then determining what bounds to use from there. Okay, so 2x squared looks something like that. And now 1 plus x squared starts at 1 on the y-axis, but goes exactly through those 2 points that we just graphed. So when they say D is the region bounded by these 2 parabolas, this is D right here. Okay. So now if we're actually trying to figure out, okay, well, which way should I do this? Should I do dy first or dx first? If you do dy first, the nice part about that is we know exactly what curves to use. Does that make sense? If we decided to go dx first, I'd have to figure out an equation for this curve and that curve, and then get x alone. Actually, no. But we have 2 separate. Well, could we do x? You need a square root no matter what, which that complicates things. It's just easier if we already start with y. Okay, so if I set this up, what is the lower curve in this domain or in this region? So that is the lower bound of the first integral. And the upper curve would be 1 plus x squared. And now, so this is a type 1 region. What 2 vertical lines is this region bounded by? Negative 1 and 1. Okay, so this is how we set it up. Are there any questions on that? Okay. Something else that you can always monitor when you're doing double and eventually triple integrals. The outer integral will always have what for bounds? Constants, yeah, numbers. Okay. The inner integral might have numbers, but if we have more complicated regions, these are where the functions are going to be located. Okay, and if we have triple integrals eventually, you're going to see functions on the 2 inner integrals and then constants for the last one on the outside. Okay, so that's like if you set this up backwards and you have 1 plus x squared on the outside, that doesn't make sense. Okay, so let's go ahead and evaluate this. It represents a hypervolume. Yes.
If you plugged in negative 1 and 1 for the second integral right now, would that be wrong? Like, do you have to wait until later on?
You should wait until later on, yes. Wait, what do you mean plug it like right now? Like,
Because you know that it's like bounded in the y, right?
well, you always want to start with this, right? So if you're thinking of plugging in these bounds first, you can't because this is going to change.
No, I mean like, because the second integral is 2x squared and then minus x squared at the top. Can you plug in the x values?
Oh, into here?
Yeah.
No, not quite, because can you plug? I've never thought of it that way. I don't. Just a guess. I don't think that can work, but we can certainly try. But let's do it this way first, because
Okay, I was just
yeah.
wondering.
Okay, so integral of x plus 2y is going to be xy plus y squared. Do you forget a term? And this is from y equals 2x squared to y equals 1 plus x squared dx. When you plug in those bounds, now we have x times 1 plus x squared plus 1 plus x squared squared minus x times 2x squared. I'm being very careful about my work right now. And then plus 2x squared squared dx. And I will, let's see. I mean, I guess you can do these a lot of different ways. I'm just going to multiply everything out. This will be x plus x cubed plus 1 plus 2x squared plus x to the 4 minus 2x cubed minus 4x to the 4 dx. Clean things up as much as you can. Let's see. Negative 3x to the 4. That takes care of those. Minus x cubed. That takes care of those. Plus 2x squared plus x plus 1. I don't think we can combine anything else. Okay. So then this is your final integral before you plug in negative 1 to 1. And when you integrate, now you get negative 3/5 x to the 5th minus 1/4 x to the 4 plus 2/3 x squared. Oh, that's not squared. Cubed, sorry. Plus 1/2 x squared plus x. Yay. And that is from x equals negative 1 to x equals 1. And I don't know what that is, but you guys can figure it out.
So you don't really need to plug it in twice. You can just do 2 times the whole thing if you
Because you
weighted it one.
because you have
Just
powers.
thing. Excellent. Because when I did it the other way, the wrong way, I was able to do that.
Yeah, because you didn't have the, yep. So this is going to equal something minus something. Generally, yes. Anybody have it? 32 over 15, thank you. So after you plug in 1 and negative 1 and subtract, you get 32 over 15. Okay.
And so that's the volume of that really random figure. Like,
So this would represent,
to the
if we graphed x plus 2y, so let's see, what are we talking about? Good question. Z equals x plus 2y. What is that going to look? That's just going to be a plane.
yeah.
Okay. So now this, okay, see if I can draw it sideways. So here's a different view of D.
Because D is
Okay. Z equals x plus 2y. Well, let's see. The intercept is going to be 0, 0, 0.
How'd you get 32? Can you put it
And I'm guessing over here somewhere, it's hard to draw without, these planes are always difficult to draw because we don't have intercepts that make it easy, but over here, yeah, I can't really draw it. But anyway, there's some plane over here, and we're finding the volume above this boomerang region, but underneath that plane.
Why?
Why what? Oh, lots of things. Well, the particular region, I mean, depends. If you're designing something that has that shape.
When we did Duffy and stuff, we had like, oh, you can calculate work to using
Oh, well, the
product.
physics applications will come, don't you worry.
Cross product.
The physics applications will come, don't you worry.
Are we gonna do like laminas?
Yes.
Aaron, I saw that in the book because we were doing center of mass.
Mm-hmm.
And physics. We actually used calculus in physics finally.
How about you guys try this one? Let's end with this. Find volume of solid that lies under z equals x squared plus y squared and above R, where R is bounded. Whoops. See, that looks like I don't know how to spell words.
bounded?
But I argue that my brain was already thinking of the next word,
Yep.
which is by. So it's not that I don't know what I'm talking about.
Are you
Normally I just write.
What's that? Yeah, it's gonna go on.
To justify.
Yeah, I have to justify. Yes, I do know what I'm talking about. Okay.
Wait, is that
Normally I write shit
R?
bounded by.
Wait, what is the like
Just-
the word before R?
Where?
The word before R.
Where?
That one.
Where?
Oh, wait, that's a where? That's a where? What?
That was even
It's-
worse.
That's not better.
I thought that's
I thought it said like
Oh my goodness.
whoa.
This is what we learn in my class, YouTube people.
Is that why you use? Is that why you use the and symbol instead of writing out and?
Yes, it's faster.
That's room for error.
Wait, above R.
All right, take some time, set up an integral, whatever way you want to do it, and let's see what kind of answers we get. Well, it's not like a live cast. Like people aren't watching this as it's happening.
But that's your
That'd be interesting.
Okay, there's no editing. Yeah, because nobody else wants to do math.
Yeah, they
7:50.
they usually watch these videos later. That's true.
Like right before the line.
It's all about supplying.
Yeah, do you have like something where you can see like
Supply and
where
demand.
people are watching?
Mhm.
So maybe it's like right
Oh,
before
really?
the final, just like a big
I'm
screen.
going.
Well, it depends.
Oh, okay.
Do you also get like the reports of where? I thought there were reports of where.
Where over the globe. Yes, it's pretty cool.
There's
People
people
from other
in
countries watch your
like
videos.
Yeah.
Asia and Africa.
People
and
from
Europe.
all over the world watch these.
Oh,
Yes.
you're so famous.
Because I
Whoa,
remember
you're
seeing this one that
famous.
is like one person in North Korea watches your video. Guess which the Korean leader likes my YouTube channel.
Kim Jong-un learns calculus.
can I ask, what direction did you guys pick?
The up down
Okay.
Type
The up.
one. Clearly, I'm maths.
Up is a direction, down is a direction.
Right hand. Oh, the hot dog.
Just so I can stop recording soon. So we started by setting this up like this. What was the lower bound for y? And the upper bound for y?
Is it 0 and
Wait,
y?
easy number.
Remember, we have functions that are boundaries here, not
No,
constants.
I was thinking of the first two.
Oh, over here. So yes, what are the bounds for x?
0 and 2.
There we go.
wait, why is it x squared 2x and not 2x?
Because if we're going y first, we're going from bottom up. What's the first curve on the lower end? Y equals x squared. And what's the curve that we hit next? Y equals 2x. So the upper would be 2x and the lower would be x squared.
Alright.
And everybody's good on the 0 to 2 part, right?
Yeah.
Okay.
Yeah, I got it.
Now, here is the answer. I don't know if anybody has it yet.
Ah. I got negative 64
Do you-
over 35.
You did it ideal, Sean.
So, in addition to maybe starting 14.2 tonight, if you did not get this answer, 216 over 35, you need to figure out why and actually get it. I'll see you guys tomorrow.